So I still need to grade exam 2. I'm posting homework tonight, and we're about to finish section 5.2. So the first part is a graph that is connected. Is a single piece. So a graph consisting of a single piece or component is a connected graph. Green doesn't show up very well, but connected graph. And if it's not in one piece, it's a disconnected. A graph made of separate pieces is...
Is that just so long? Is that just so long as any of the lines are connected? That it'll be a connected graph, like even if it's not like, say, in the shape of a box, where like all lines are connected and it has an enclosed space, even if it's just like one line kind of just going all over the place, even if it doesn't like make a closed shape, it'll be still connected.
Yeah, connected is not the same as closed. Like, this, like you said, box shape would be connected. But this kind of maybe shape like this, that's also connected. So this is like one, well, also, this is a separate example. So graph number 1, graph number 2, that's connected, that's connected. Something that's disconnected, but first let's write it down. So graph. Made. That's okay. So more than one piece or component is disconnected. Okay, so everything under here is all the same graph. We're going to have a part here. There's a piece over here that goes to this, and it goes swoop. And I put a little just point to point on the side. So this would have 3 components, and it's disconnected. So there's different pieces. Okay, let's see. I think that's all there is for the definition part, and then we do examples. And I also want to practice finding the degree. So for some of these, we're finding degree. For some of them, we're looking at how many components. Okay, so new graph. It has 3 dots and then 1 down below. So we're gonna go here, 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 and straight over. So 4 vertices total. We're going to connect and connect. And let's just go straight here to here and make sort of a heart shape like this. I labeled the top vertex G. Cross, we go H. And I put E. So let's start with the degree of G. That's for degree of G. Is the number of edges that connect to G. So we're going to highlight how many times we have a connection. 1, 2, 3, 4, 5. Let's do F. Degree of F. So it's 1, 2, 3. 3 edges meet that vertex F. We'll go to degree of H. B3. Same for E. 1, 2, 3. All right, let's just talk a little more about this graph. It is connected. There's one component. Okay, let's go down here to the next picture. We'll have, let's do 2 components and they're part of the same graph. Okay, the first part is.
Professor, this might be I might have a kind of a silly question, but I kind of want to ask it anyway. For any connected graph, like say you're asking us, hey, is this connected or disconnected? A connected one will always be one component, whereas disconnected could have any number from two or more, correct?
Yeah, anywhere that's strictly greater than 1, 2, 3, 4. And also like numbers you can count on your fingers.
Right. Okay, cool. Thank you.
Yeah, like right now to get to just having 2 components, that makes it disconnected. We're gonna go with dot. It has a loop. It has a dot over here and a dot over here. And we're going to, let's go swoop, straight, swoop, straight. And then another piece part of the same graph. There's 1, 2, and then let's go straight up and put 2 more vertices. Okay, this piece has 1, 2, 3, 4, 5 vertices. We're going to make a triangle right here. And we're going to make a triangle on this side. And a triangle from that side. Okay. And, I think, well, we're not going to label this. We're just going to put that shorthand for like the degree and label each vertex with its degree. And I think I want to find how many components, and let's also find the total, let's see, how do I say this? The total number of degrees. We'll hold on to that. Okay, first, the degree. Right here, we have degree 2. There's 2 edges that connect. It's a little hard to see this, but the loop contributes 2. So there's 1, 2, then 3, 4, 5, 6. Let's check it out. 1, 2, 3, 4, 5, 6. And then this vertex here has degree 2. Okay, then to the other component. Start at the top. We have degree 2. This is also degree 2 and 2. And 1, 2, 3, 4. 1, 2, 3, 4. So I think I mentioned something about finding the total number of degrees, but I'm pretty sure that's only for connected graphs. So I'm going to skim through the notes, but let's just focus on degrees, connected and disconnected. We're at a disconnected graph. All right, we've got more than one component, 2, so it's disconnected. Okay, new example. Okay, we're going to label each vertex with its degree. And this graph is going to have 1, 2, 3, 4 components. All right, starting with this piece where we've got a triangle. And on this side, 2 loops. Then we're going to go here and start the next piece. We will go 1, 2, 3, 4. And we're going to connect this right there to the next piece. We have a diamond. We're going to connect here, come up, the dot there. And the last piece. Is kind of an X. Start with the X shape. And we're going to go across and put a loop. I feel like I want, somewhere I want to put multiple edges. Let's put an extra connection here. Okay, so reminder, these here, like this and this is a loop, 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 and that's a loop. Right here are multiple edges. We have an edge between 2 dots more than once. Okay, we're going through with the degree. This would be degree 2 and another degree 2. This one starts with 1, 2, and you get 3, 4, 5, 6. Each loop adds 2 to the degree. 1, 2, 3, 4, 5, 6 total. So this is all the same graph, and we're on the next component with degree 1, 2, 3, 4. Degree 2 and 2. Cool. We're at degree 1, degree 2. Oh, that's a 3. That's got 1, 2, 3 connections. Okay, here are 3 connections, and that's a 3. Last part. Let's get this. That's a little better. So start with this loop. We've got 1, 2, 3, 4, 5. Let's go down. Let me put this over. Degree 1, degree 2, degree 2. And I think we're done. So we've gotten the degree of every vertex, and I think the last thing we want to do is talk about how many components. So we're still working on this example, but okay, we've got 3 components, which means it's more than one component, which makes it disconnected. So this piece, this piece, this piece, this piece, and let's try something new. Okay. So let's do one more example here, and then I think we're going to go and do some kind of word problems. So, how many components does the graph have? And label each vertex with its degree. I'm going to try it. Okay, so we're going to do this. First one will be, let's just do this. And we're going to make a triangle here, here, here. And like this. And on the side, we were going to put 3 dots. And these 2 here, we're going to connect. That's it. So that's my graph. How many components? We have 1, 2, 3, and that is 4. 1, 2, 3, 4 pieces in this graph. And we're going to go through each piece and find the degree of every vertex. So right here, this would be degree 1. And this is a 1. This would be 2. That's 2, degree 2. Here we have 1, 2, 3, 4, degree 4. This one's degree 1, degree 1. Let's go here. What do you think this degree is? How many lines connect? How many edges connect to the dot? None. Let's see. We have a guess. Yes. Cool. Thank you. And that's degree 1, degree 1. Okay, so I have these problems that might seem sort of random, but we want to be able to apply what we're learning to some real life problems, and I was able to find some. So let's see, that would be here. So there's a lot of writing involved, but in the end, we're going to find our answer by drawing a graph. So we have 2 teams of 5 people, and they've just played a game. Everyone on each team is going to shake hands with everyone on the opposing teams. This is pretty. But no one from their own team. And how many handshakes occur? Okay, try to make it work. OCCUR. So we're going to draw a team with 5 people, and those are like 5 dots. And the other team will be my other group of 5 people, kind of like next to them. Okay, start with team number 1. And you will go up and down. The next team will put kind of over to the side 5 people. So no one from this team will shake anyone's hands from their own team. So none of these dots are connected to each other. We're only going to have connections from here over to the other team. Let's start with this person. So this person's like does a handshake with first person from the team, and the next person, and then the next person, and the next person, just once per person. Then we say this team member shakes hands with everyone from the other team. So draw a line from that dot to each of the 5 dots on the side. So the blue team has this third person who says hi to each of the other people on the other team. Okay. This person, same thing, connects with each of these dots. And here, connect, 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 connect. So what we're going to do is find the degree of each vertex. And I realize now that we need a result. So we're going to have to put this result to the side. It's from some other notes. But before I go to find that, we've got degree 1, 2, 3, 4, 5. This one also has degree 5. So degree 5 and 5. All right, this is also 5 connections, 5 connections, 5 connections. Okay, then I need to go look through notes, and while I do that, I'm just gonna explain that I used to do a lot of group work, and so I used to hand out packets with just problems for the students to solve. And not a lot of them work well online, because especially with all of this drawing. So I have to skip around and find the pieces that we can do together. From old notes. Cool, cool, cool. Can't draw that stuff. Okay. So there is a relationship between the sum of the degrees of all vertices and the number of edges. The relationship is that the number of edges is half of the sum of the degrees of all vertices. So you have to be sure to find all the degree of all vertices, add everything together, and then divide that by 2. That will tell you how many edges there are, which is what we want to know for this problem. The number of edges will tell us how many handshakes. So we add all of these degrees together, all of those degrees together, take that total, cut it in half, and that will tell us the number of handshakes. So it's 5, 5. There's 25 here, and another 25 on this side. So add all the degrees together, and you get 50. And then we need half of that to know how many edges there are. So we get 25. "25 handshakes." Okay, so back to doing more word problems. We will have 5 people meet at a table. Everyone gets up and shakes hands with everyone who did not sit next to them. How many handshakes occur? I don't know. I keep putting this. Five people sit around a table.
For the previous one, it was 25 handshakes occur, right?
Yeah, the answer was 25. Everyone gets up. Shakes hands with everyone who didn't sit next to them. So there's really no formula for finding these. Sometimes you just have to draw what you're being told and then kind of use that theorem if possible. So how many handshakes occur? Okay.
Could I propose a formula?
Oh yeah.
I mean, so if you have the 5 and you put them in a circle and figure that each person has a person on their left and a person on their right. So that's the person that they wouldn't shake hands that's sitting next to them. So you subtract that. So you get 3 3 handshakes, Oh wait, no. 2 handshakes because you're one of the 3. And then take that 2 because it's you. You can't handshake the person to your direct right or direct left. So you have two remaining people that you shake hands with. So those are how many handshakes each person makes, and you have 5 people. So 5 times 2 equals 10. So 10 handshakes.
And then we'll see. A lot of what you described, though, would help if I drew it. But you take that 10 and divide by 2, and then it's 5 handshakes is the answer. Let's see.
Oh, perfect. All right.
Yeah, we are going to kind of drop, I think, most of what you said. The 5 people will have in a circle. Like this. 1, 2, 3, 4, 5. Okay, pick a person. And they do not want to shake hands with that person or that person, but we can go across here, and that's okay. Make sure you connect all the way. And all the way here, get that connection. And that person's done. This person is not going to connect with that vertex or that vertex, but we can go here and here. This person does not shake this person's hand or that person's hand, but these two are okay. I've already done that. And I think we're good. So this person's not going to shake those people's hands, but we can go to these people. At the top, we're not going to say hi here, but we're going to go across there, and then we're at the beginning. So we've taken care of like thinking through the event. Now we want to see how many connections, which is going to tell us how many handshakes. So to get the number of edges, let's add all of the degrees together. 2, it's degree 2. That's 2. So for handshakes, it's kind of like how many edges are there? So we'd find the number of edges by adding all of the degrees together and divide by 2. So it'd be like 2, 4, 6, 8, 10.
Oh, okay. I see where that one theory I said falls short, because then you have to figure if you go around to each person, there'll be duplicates of people if you're like counting them. So that's why you divide it by 2.
Mm-hmm. Yeah. Because it's like one handshake goes for both people. So let's take the number of degrees. Oh no, number of edges is going to be sum of degrees divided by 2. Okay, we're going to put all right, let's see how many more we can do. We'll start this problem. It has multiple parts. Okay. Some attendees at a convention connect with one another by exchanging business cards. Let's just say some people exchange business cards. If two people exchange cards, they have made a connection. Let's see. And well, we understand that. And how many connections are made if let's see, how many card exchanges are made if, and then we'll go to part A. Okay, so the first scenario, if 6 people each end up with 3 new cards. Okay, so we're going to draw 6 dots. Our vertices / dots, they represent things like people and other things that we're interested in. And the edges represent relationships between those things. And the relationship right now is a card exchange. So 6 dots, I have them like, I need space to draw. So make sure you had that. We're exchanging business cards. And part A has 6 people. Kind of spread out. So in class, you'd usually play with this to get this event to happen, but I have kind of an answer key with me. So let's start here. I went 2, 3. Hopefully we can get this. 1, 2, 3. So that person's done. They've exchanged cards with people 3 times. This person. That's 1 exchange, 2, and 3. So that person's done. Here, we've already gotten 1 card. And I got another and another. This will also need to be degree 3. 3 connections. This person needs to get 3 cards, and I connected here. And then we're at that person, 1, 2, 3 cards. 1, 2, 3, 1, 2, 3. So we're good on all of the people have each gotten 3 cards. We didn't have to draw this picture, but it helps. So each person or each vertex would be degree 3. There's 6 people, so we'll have 18 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you add it all together. Okay, we're only using this to find the number of edges. That gives us the number of connections or card exchanges. So take the sum of the degrees divided by 2. So we'll have 9 new cards. Okay, so we're gonna keep doing parts to this problem, and I think it will be okay. Yeah, I was gonna say maybe there's a formula, but even just the next piece has something different going on. So we're gonna have 3 people who gain 4 new cards, 2 people who get 3 new cards, and 1 person who gets 2 cards. So we're just gonna have to draw. For part B, 2 people get 4 cards. There are 2 people who get 3 cards. And 1 person gets 2 cards. So how many people total? 2, 3, 4, 5 people. Put them like this. And usually in class we kind of play with how to draw the picture, but I'm going to just help you draw the picture using like my previous work. So I started with this person and had them collect 4 cards. We went 1, 2, 3, 4. Oh, actually, I misread the problem. This part is the number 3. There are 3 people who get 4 cards. 3 with 4, 2 with 3, 1 gets 2. Okay, so I had the other 4 cards go here and here. So we're going to go 1, 2, 3, 4. And on this side, I skipped this dot and went 1. There's 1, 2, and then now we're at 3, and that's 4. So I was trying to have each of those have degree 4. They've each gotten 4 cards. This person has 3 cards. This person has 3. And this person has 2. So that's it for the picture. And being able to like visualize and label each vertex with its degree and find the sum of all of the degrees. Okay, so 4 plus 4 plus 4, which would write that down. Add 3, and another 3, and 2. So 12 plus 6 would be 18, 19, 20. So we take 20 and divide by 2. That will give us the number of edges. 10 new cards. I think we have time to do at least one more, and that'll be it. Okay. Let's do this one. It's kind of easy, and then when we come back next time, we're going to keep working on problems like this. So this part is part C. We have 2 people each get 4 business cards. And 4 people get 2 cards. Two people here, 4 people there, so 6 people total. And we'll put them, I actually did 1, 2 for those guys, and then I put my other 4.
Professor?
Yeah.
So this is just a general question regarding like each of these like multi-part steps. We, upon starting each of like the steps, we're resetting the drawing, right?
Yeah.
Because we'll be given a different set of instructions on like how many connections are made and this and that type stuff.
Yeah. So yeah, a whole new graph for this. And there, like when we do a problem, let's see, I guess next week, it will lead to a formula, but not every single situation has a formula that's like easy to recognize. So you might just want to draw, like, redraw everything. Okay, our 4 people are going to go down here. These 2 people are going to connect with all of those 4 people. 1, 2, 3, 4. And same with this person here. We'll go 1, 2, 3, 4. And it's easy for me because I've already played around with drawing this before, but it usually takes some time to get that degree. 4, 4. So 2, 2, 2, 2. So we find the sum of the degrees and divide by 2. That will give us the number of edges. Okay, 4 with 4, 1, 2. So 4 plus 4 plus another 4 and 4. This would be 16. Divide by 2, and that will be the number of edges. I want to peek. I think there might be a sort of way to skip the drawing. So let me think about that. We have some time. So let's try doing it with a question. So I have this question where it says, explain why we can't have one person. Oh, yes. I see a hand.
Yes. Yeah. You know how, in the terms of like graphing, there's like Desmos online.
Oh, yeah.
Do you know? Do you know if there's like any like what not website? I guess you'd call it a website that exists where you can input number of edges, number of degrees, where like it'll give you a drawing. Like, do you know if anything kind of exists like that?
I think it does. I used, so I just went onto Google and found ways to draw all of my graphs, like the ones that'll be in the homework. But I didn't actually use a calculator. I also found one or two graph related apps that were games. So I do think that would be, there is a calculator out there, but I've never used one. So I would just try Google. But you'd have to be able to draw your graph, and
And
then
just
once
search
you
in
draw
like the
the graph,
criteria.
you'll be able to click on it and have it tell you degrees. Anyway, let's do one more piece of this problem. I knew I said we'd kind of wrap it up, but I want to try to see if we can talk through it without having to draw. Okay, so this will be the last thought. Explain what's wrong with the following situation. Okay. One person gets 4 cards. And 2 people get 3 cards. Two people get 2 cards. And 1 person gets 1 card. So I don't have a drawing. I have kind of like the sum of the degrees. So I have 1 times 4. So 1 person has 4 cards, means there's 1 vertex with degree 4. And we'll label, once we kind of get all the information here, we'll erase and label where all those numbers are coming from. Add some 2 people who get 3 cards. So there are 2 vertexes, or 2 vertices that have degree 3, that had 3 connections. Two people or 2 vertices that have 2 cards. So 2 vertices that have degree 2. And then there's 1 vertex with degree 1, with only 1 connection. So each number outside parentheses was the person, and in parentheses was the number of cards, or like that vertex and its degree. So every person is represented by a vertex. And each card is a connection or an edge. And then just, again, that's the number of people, that's the number of connections, or the number of edges, vertices and degree. Vertex, degree, vertex, degree. Okay, so the sum of edges, sum of degrees is 4, add 6, add 4, add 1. Ten plus 5. Excuse me. Okay, so we take the sum of degrees, divide by 2, and that gives us the number of edges. And then you get like 7.5, which would be not good. There's an issue here. Okay, you cannot have half of an edge. Just like you can't have half of a handshake or half of a connection. It just has to be a full connection or no connection. So hopefully the explanation there helps to see how you don't have to draw the graph every time, but it does help to draw a graph. And also, if you do have a graph, the number of edges needs to be a full number at the end. And we're done. Okay, thank you for coming to class.